There you go. Hey, everybody. Today's topic for study group, data analysis in pandas. Same, different title, but same content. As I was saying just before the recording, I'm going to be assigning pairs twice this phase. Once to work on a mini project, which I'm going to talk about in a little bit, and then once for your project. Again, I'll be taking time zones into consideration. So if anyone has travel plans or is going to be in a different time zone, let me know so I can take that into account. But if you take a look at topics 4 and 5, there is one cumulative lab here, sort of like a mini project. And there's also one cumulative lab here. What I will have you all do is you and your partner, and I'll post these project pairs. I'll post these cumulative lab pairs right after this. You and your project partner pick one of these to work on. You don't have to work on both, just pick one of these to work on and work on them together. How you submit them, I'll talk about that tomorrow, but I think it's just a good opportunity for you all to, just to meet other people in this cohort, have some quality working time together. It's going to be very, very important. Yeah, so look out for that. I'm going to post project pairs sometime later this afternoon. And then for the project, which if you take a look at our calendar again, I'm actually going to give us a little break between topics. We have Memorial Day next Monday, and then I'm going to introduce the phase 1 project on Tuesday. I'll be assigning another set of project pairs. So look forward to that. Okay. Oh, one more last thing. As I see right here, this Thursday at 12 p.m. Eastern, there's going to be an Intro to Career Services talk. So this is not just for this cohort, but also for every other cohort that has started around this time. Really good opportunity to just be aware of what career services does. I would say at this point of the program, you don't have to worry about career services so much yet, but they're going to have that session for you to just get to know what they do and how they are going to help you when you graduate in a few months. Cool. Questions about that? All right, well, I will post the cumulative lab instructions as well as the project pairs sometime later today. But with that, let's get into Numpy and Pandas. So a bunch of overview here. I pretty much copy and pasted this from one of the labs. But even though the main thing is Pandas, I do want to talk a little bit about Numpy. So Numpy and Pandas are both Python libraries, pre-written pieces of software that you can reuse rather than having to write your functions yourself. So yeah. The first one we're going to talk through are Numpy Arrays. Numpy actually stands for numerical Python. So I hear some people say Numpy, which is fine, it doesn't matter, but it's Numpy for numerical Python. We will get more into Numpy in phase 3 when we talk about linear algebra, but for now, some of the concepts that go behind Numpy actually translate into Pandas. So I want to use Numpy to just demonstrate a few things later. And the main data type we'll be working with in Numpy is arrays. Let me zoom in a little. Okay, we'll be working with arrays, and I'll show you why that is actually sometimes better than lists. We'll see in a little bit. And then the main thing we're going to talk about today is Pandas, another Python package designed to work with relational data. Relational data is basically anything that is in the form of tables or like CSV files. Really, really great tool for data wrangling. A lot of your interviews are going to be working with Pandas methods. So good to know. Designed for quick and easy data cleansing, manipulation, aggregation, and visualization. So within Pandas, there are 2 main data structures. We have series, which are 1-dimensional, and data frames, which are 2-dimensional. When we take a look at documentation in a little bit, we'll see what the main differences are. Bullet point here, but we'll go through all of these later. Okay, so first, let me bring up this on this side. I like to have this to follow through. Okay. So first, we're going to talk about Numpy arrays versus Python lists. So what we have here, import Numpy as NP. This is basically an alias. NP is an alias for the library Numpy. It basically saves us from having to type the full 5 letters of NumPy. Instead, we just type NP. How this works is whenever we want to use something out of NumPy, for example, the array data type is part of NumPy, we use np.array to use it. And because we alias this, we can do np.array. If we import NumPy as something else, and NP, by the way, is an industry standard, so don't do this as anything else. But if you want to import NumPy as like, I don't know, let's see, my, I don't know, as an example, it kind of does the same thing. So if we do like my.array 1, 2, 3, that does the same thing. So this alias is just an alias, but please use NP. That is the industry standard. So import NumPy as NP. If you want to turn anything into an array, you just throw it into np.array. You just coerce whatever structured data into np.array that turns it into a NumPy array. So here's a NumPy array, 1, 2, 3, 4. And you know it is a NumPy array because when I look at the type, it tells you it's a NumPy ND array. I forget what ND, oh, n-dimensional array. That's what that is. But it's an array. Cool. These are more advanced data types. We will get way more into this when we talk about linear algebra. But when you have higher dimension arrays, which are basically nested lists, these are what they're called. So you can see here, if we have just a straight up list coerced into an array, it's known as a vector. This terminology not important for now at all, but good to know. If it's two-dimensional, as you can see, it's nested lists within a list. If it's 2 layers, something like this or something like this, it's called a matrix. Anyone who has seen a little bit of like linear algebra, I think at some point, if you did like, I don't know, some level of high school or university math, there's matrices in there somewhere. That's what that is. And then if you want to go another layer, so nested lists within nested lists, these are called tensors. Not super important to know for now. But what this also shows is on an array, you can do dot shape to show you the dimensions of the array. So dot shape is a useful one to remember. So now that we've introduced arrays, these higher dimension arrays, we don't have to worry about so much for now. But with arrays, you can index them. So for example, this is a tensor. And an example of something that is a tensor is an image. Images are actually tensors. So as you can see here, we have 2 sets of like 2 by 2. So if you imagine an image, let's say you have like a 128 by 128 pixel image. One layer of that is a matrix, but images have color, right? So if you have an RGB image, the way that images work is you have one matrix representing all the red tones, one matrix representing all the green tones, and one matrix representing all the blue tones. So that put together makes a image tensor. So yeah, you can index all these arrays. So finding like the first tensor would be this one over here. These higher dimension, again, I want to stress, not super important for now. So what makes an array better than a list? It supports this thing known as broadcasting, which is a super, super powerful tool. So basically this happens when you perform operations across arrays with different number of dimensions. And again, we have some examples to show how this works. So what broadcasting does, and actually let me do this real quick. So actually, wait, I have print statements already. Okay, so what this is, we have this scalar, which is just the number 4. And we have this vector of 1, 2, 3, 4, 5, 6. I can do operations between a vector and a scalar, between 4 and this list of numbers or this array of numbers. When I do vector plus 4, what it's done is it's plus 4 to every single element in the array. I didn't have to do like a for loop. I didn't have to do a list comprehension. That's broadcasting, and that's something that NumPy arrays do. So what NumPy does is it makes duplicates of the lower dimension array as long as the higher dimension array contains the same shape to execute the operation. So yeah, basically, if you remember last study group, we were doing like list comprehensions for like x+2. You would have to do like x+2 for x in list. In this case, because these are arrays, it automatically broadcasts, which sometimes you want, sometimes you don't want, but very, very powerful because the computation time of this and computation power of this is a lot lower than doing like a for loop through a list. So that's good to know. When is it not possible? So let's take a look and just like intuitively, if I had this one-dimensional list here of 101, and I had this matrix over here, let me just comment this out so we can see what these look like. Let's print V1 and then print M1. Okay, so V1 looks like this. M1 looks like this. Let's just see how they broadcast on each other. So what I did here was I tried to take like, okay, this list of 1, 2, 3, 4, 5, 6, add the number 4. Here, let's try and do that same thing, but with higher dimensions. So M1 plus V1. Okay, so it says operands could not be broadcast together with shapes 3, 2, and 3. You might think, okay, but the 3 kind of matches. Why can't it broadcast? Well, if you take a look at this more clearly, let me zoom in again. This 101 doesn't know how to flip itself to broadcast onto this shape of a matrix. So just to contrast, what does work is if I have something that instead looks like this. Let's see, so it contains shapes of 3, so it knows how to broadcast the 101 onto this. So now if I do M1 plus V1, that works. It's added 101, it's added 1 here, 1 here. So just wanted to show you that Numpy Arrays is what supports broadcasting, and Pandas, which is what we're going to talk about in a little bit, is really, really powerful because it does broadcasting on a lot of these elements. So really, really good concept to be aware of, broadcasting. Cool. Just as a quick exercise, oops, I did not do this yet. Where's Tensor 2? Oh, I guess right now it's just Tensor. All right, if we had a Tensor here, what shapes of matrices and vectors can be broadcast onto this? This is actually an exercise for later, so don't worry about it now, but you can sort of see, all right, if as long as I have anything with this shape here or this shape here, I can broadcast. Just really quickly, if I do like Tensor plus 5, you can see that it's added 5 to every element. So just like that, broadcasting, rather than having to loop through every single thing and be like, for this and this, for this and this, because this is a nested list, broadcasting is great. Last thing with arrays before we move into pandas, you can create arrays that are very useful in practice. So just as an example, np.zeros will help you make an array of zeros. So let's just say I want like a 5 by 5 thing of zeros. Oops, you want the shape to be like this, I believe. There we go. So shape of 5 by 5 of zeros. Same thing works with ones. And same thing works with full. And for full, this is a shape. You can fill it in with whatever you want. I think you can even fill it in with strings. So maybe you want to fill it with a string 8. That's what you can do there. So just useful ones to know. Honestly, we won't be doing this too much right now, but in later topics, this will come back. Cool. So main point here is that Numpy arrays support broadcasting. I want you all to remember that it does broadcasting, and broadcasting is also what makes pandas, which is what we're about to get into, very, very useful. All right, so with pandas, the alias we have here, which again is an industry standard, is PD. So we're always importing pandas as PD. Yeah, just don't be chaotic and import it as something else. Okay, so getting data in and out of pandas. We will be working with a lot of CSV files. If anyone doesn't know what a CSV file is, it stands for comma separated values. And it's basically like a single sheet Excel. Excel sheets are different because you can have like multiple sheets, but CSV is just one. A lot of our table form data exists in CSV files. So what makes pandas really useful is it has a read CSV method already built into it. So all you have to do is pass in a CSV file name. For those of you who have downloaded these notes, you can see that I've put a CSV file name there, a CSV file in there. You can click into it if you want, and you can see that this is our data all separated by commas. This read CSV method is really, really useful because it automatically takes this data and turns it into a very nice looking table like this. So read CSV, very useful. It's going to come in handy for our project. Quick tangent. You can also throw things into a CSV file using pandas. So let's just say car_df, and df is actually another industry standard variable for saving data frames. df stands for data frames. So car_df is our variable that has this data frame. If we want to store this and save this as a CSV, just for as an example, maybe I do a bunch of data cleaning, maybe I like edit a bunch of these values and I want to save this as a CSV. You can use the toCSV method. And all you have to do is pass in the file name that you want it to have, and that actually saves it. So let's just run this real quick. We're going to save this into a CSV file called cleaned cars. Let's run this. And in our homepage here, you can see that now there's this seconds ago created new CSV, which is the same thing right now. But yeah, that's how you read and write CSV files. Okay. So we kind of talked about this a little bit on Friday, but you can turn things into pandas data frames. So let's just store this data somewhere. We have these Spanish numbers, this dictionary of numbers. Run this. Pandas allows you to turn things from a dictionary into a data frame as well. So if I run this, you'll see that just like that, this dictionary has automatically become this kind of like data frame. By default, the column names, if you don't tell it what it is, by default, they'll number, but you can actually edit that. And the way you edit column names is you can just feed it in a list of your column names. Here, I only have one column. If I want to change that name, I just give it numerical. So if I rerun this, you can see that the column name is now numerical. The way I add a new column to a data frame is very, very similar, or actually pretty much the same syntax as adding a new key value pair into a dictionary, if anyone remembers that. We call on the data frame. So let me just add some comments here. It would be to add new column to data frame. It is the data frame, new column name equal to new column data. So in this case, let's just say I want to add a new column with all the Spanish numbers. And I save that here. So the syntax will be the numbers data frame, Spanish column, add Spanish numbers. When that's done, we'll see that I have my Spanish column. Of course, your data frames are going to be much, much bigger. Okay, so let's use a bigger data set to just demonstrate some pandas functionality. Don't worry about this part too much, but this is actually just loading a bunch of pre-built data sets and libraries. So let's hope that this runs. I knew that this was going to happen. Give me a second. Basically what happened is I updated my computer and all of my libraries were uninstalled. So let me just do this really quick. So as this downloads, are there any questions about anything so far? Okay, there we go. Hopefully this is okay. Nice. So yeah, if something like that ever happens, say no module name whatever found, usually what you can do, you can just pip install or conda install that in your computer. So okay, this is all good now. So what I've done here is I have loaded this built-in data set about wine. This is just a wine data set with just, I guess, 178 rows of wine. And I think this is all of their like the chemical makeup of all the wine. We're just going to use this to demonstrate some pandas functionality. So let's say we have this data. Let's see what pandas can do. So two main things. There are attributes and there are methods. If you've ever thought, okay, with this like method or with this function, when do I need to add the parentheses at the end of it and when do I not? Attributes have no parentheses, methods do. What is a method versus what is an attribute? It really depends on how the library is defined, but these are some attributes of data frames. So this wine data frame is just called DF. Again, DF stands for data frame. Most of the time, attributes are like characteristics. Again, attributes are the ones that you don't add parentheses behind. I'll show you what happens when you try to do so. So let's just say I want to find the shape of this data frame. Basically tells us the dimensions, 178 rows and 13 columns. If I try and do like parentheses at the end here, it's going to tell you that it's not callable. So if you run into an error, but you're absolutely sure that this is right, try taking away or putting back in parentheses. But anyways, shape tells you the dimensions of your data frame. Index will show you the index of your data frame. And by the way, an index is basically this like leftmost column. Sometimes this has more meaning. A lot of times it's really just running numbers. You can also do dot columns. Dot columns shows you all of the column names that you have. Another really useful one is dtypes. Dtypes basically tells you what the data type is for each column. If you've ever seen like float 64 and like how different is a float 64 from regular float, basically in pandas and several other kinds of data as well, float 64 just means that I think it can support up to 64 digits, something like that. So that's what that is. You might see like float 32. I think that's another one, but all floats anyways. Okay, so those are all attributes of data frames. There are other attributes as well, but none that I can think of off the top of my head, but there are a bunch of attributes.
Okay. .info is cool.
.info is cool, but .info is a method, which is different from an attribute. And I actually am just about to get to .info over here. So the difference between attribute and method is the one that you have to add parentheses to. And usually methods do some sort of action on your data. So yeah, let's talk about methods. Dimitri mentioned .info. .info is a great one. .info, what that does is it kind of summarizes all the info of your data frame. So it'll tell you how many non-null values there are, and straight away also tells you the data type of all of the columns in your table. So this is a really neat one. Another one that's neat is .head and .tail. You'll see that a lot, especially as you are exploring your data frame. So .head shows you the first 5 rows of your data frame. Sometimes you have like a really, really large data set and you only need to look at the first 5 to just quickly inspect it. .head is useful. With these methods, you can usually give it arguments. So I know for .head, if you just want to preview more rows, you can do like 20 and it'll give you your first 20 rows. .tail, exactly the same thing, but as the name suggests, it gives you like the bottom however many rows, and by default it is 5. So by default, it gives you the last 5. We looked at .info already. .describe is a great one too. So .describe gives you like the statistical summary of your data. So this one is neat. You can see that for each column, and this will also automatically do it for each numerical column only. It won't throw you an error if you have like strings as your data sometimes. It'll tell you how many values there are, what's the average, standard deviation, min, max, your median, interquartile range, 25th and 75th percentiles, all that, all done for you. This one's a really neat one, is na.sum. I like that one a lot. So I'm going to use this to, again, talk about broadcasting. So let's just start with the is.na. What is.na does here is it broadcasts across the entire data frame, whether the value is null or not. So a lot of times you have missing data, and in some of your lessons, you'll actually encounter data sets with a bunch of missing data, and you will have to figure out how to work with that. And we'll also work with that more tomorrow at tomorrow's study group. But really neat, we can broadcast is.na across the entire data frame. you can see that, well, we didn't see any missing values. So all false is here. But the dot sum is really neat because if I do dot sum, it automatically sums together all of the trues and falses within each column. If you remember, we talked about this last week. True always has a value of 1 and false always has a value of 0. So because these were all falses, this sums up to 0. You can stack methods, and you can stack as many methods as you like as long as they make sense. If I just want to see how many null values are in the entire data frame, I can do dot sum twice and it'll tell me 0. So I like using isNA.sum a lot just so I can see, okay, really quickly, which columns have null values. Nice. Anything else at this point? Okay, so let's talk about selecting data. There are many, many different ways that you can select data. And I'm going to talk about a few of them. Actually, if you look up on like Google towards data science, there are actually a lot of articles written about the like 10 different ways you can select data in a data frame. Selecting data is useful because sometimes you want to work with subsets of your data. And based on what kind of subset you're looking at, you might want to select things differently. So the main ones are iloc and loc. Iloc stands for index locate, I think, and then loc just stands for locate. So let's talk about iloc first. So we have our DF, our data frame here, and the syntax of loc and iloc are both in square brackets. Remember that they're in square brackets. That's like the only method that uses square brackets. How you do this is you use integer location-based indexing or selection by position. So as you can see here, it takes in 2 arguments, rows and columns. So I'm just going to put a column in there. If I just put a comma in there, it's going to throw an error. But what I also want to show you all is, wait, let me undo this first. Let's undo this first. Let's just say I want to get the first 5 columns and the first 10 rows. To do that, it works like indexing. So you can do a slice as well. First 10 rows and first 5 columns. Why is that not working? Hold on. Oh, because I didn't do iloc. That's why. All right. So 0 to 10, 0 to 10, 0 to 5 works just like this. If I don't have the 0, that should also work. There we go. So if you want to get like a very specific subset and you know exactly how much data you want to see, that's what you can do. You don't have to start at the top. You can also do like, let's say I want columns. Right now it doesn't matter so much, but columns 2 through 8, I can do that as well. So that's iloc, index locate, just like slicing in a list. The next one is .loc, which shows you via, you're basically selecting based on index or columns. So in this case, our index is numbers.
Can you do 2 columns that are right next to each other? Like, can you do 3, 7, and 8?
Oh, good question. I don't know. I don't think so because you would have to separate it by, yeah, that wouldn't work. But I'll show you a different way that you could do that with regular .locate. But yeah, that's a good question. Usually for, what do I do here now? Oh, right, because this is iloc. Actually, let me try. Yeah, I don't think this will work because once it sees a comma, I think it thinks that you're looking for the next thing already. So yeah, too many indexers. So that wouldn't work.
Even if you put it in like brackets or something, it wouldn't work?
Let's see, like this. You know what? Let's pull up the documentation. PD iloc. I haven't looked at that in a while, to be honest. So let's see. Oh, a list of array of integers. Okay, so that might work. Let's see if that works. Good call. I haven't tried this in a long time. Let's see if this works. Very nice. Awesome. Thanks, Naomi. Learn something new. So yeah, if you want to get specific column, you can do that. But typically, if you want to get specific columns and the columns have names, I do want to mention that sometimes it's easier to look it up by the actual column name. Because sometimes it's hard to associate like, okay, the position with the name. And as an example, let me pull up the data frame so I remember what columns there are in it. Okay. So one way to do this is, let's say I want to get the first 10 rows using .loc, and I want to get some specific column. Sometimes it's easier to do it by name. And what I mean is, let's say I want the ash column. I'm just looking for the shortest names right now, the hue column. And let's see. Oops, I have extra brackets. And let's see, alcohol column. So sometimes it's easier to do it this way, so you can pick up the specific columns that you want without having to say, all right, this is the third one, this is the fifth one, so on and so forth.
Yeah, that makes sense too.
Yeah, but that was a good question. So yeah, in this case, this .loc works with the numbers here just because the index happens to be numbers as well. So take that into account. .loc also works with conditional lookup, which is pretty neat. So .loc takes in conditions. So let's say you want to find anything with alcohol greater than 13%. So first, let's take a look at how the broadcasting works. And this is actually pretty neat too. Let's just say, okay, let's look at alcohol. And if I ever wanted to pull out a single column, you do it very similar to the syntax for dictionaries. So let's say alcohol, cool. And this, by the way, is a series, which is what I meant by the one-dimensional data type. If I look at the type, it says it's a series, versus if I do this, it is a data frame. So let's look back at this, the alcohol. And let's just say, okay, let's just look at the ones that are greater than 14. You can actually do this, but it spits you a bunch of true falses. So this is broadcasting, because we're broadcasting this condition of greater than 14 onto the alcohol column. One other thing I wanted to note, there's different ways to do this in terms of syntax. So you can do df alcohol, right, does this. Another alternative is you can do df dot alcohol. Exactly the same thing. So if you don't feel like doing the square brackets, you can do this. You run into problems with this if the column name has like a space in it. So be aware of that. Okay. So df.alcohol greater than 14. This is a condition that we can actually throw into here. And what this broadcasting does and how that works with .loc is, let's say I want the rows where df.alcohol is greater than 14. Copy this, put that into here, and there we go. The way you use this is, what is going on here is the .loc is going to look for rows where this evaluates into true. So it's only going to take like row 0, row 3, 177. So you can see here 0, 3, 177, and only takes those rows. And this is how you can mess with like the columns that you want. So let's say you want these columns, maybe you want like, I think magnesium was one as well. So if you want to mess with the columns, you can do that as well. This is also how you can like adjust the order of your columns. So if you want to change the order of your columns, let's say you want to have like it to be, I don't know, alphabetical. I could do, oh, alcohol comes first. I could do this, and it comes in the order in which I pass it into the .loc here. So if you ever wanted to just quickly adjust the order of your columns, you can do that as well. Or I think you can also do it by numbers. So if you wanted to do like, I don't know, 1 through 3 first, I think this is how you do it. Maybe you want to do 1, 2, 3, and then 8, and then 7, 6. Nope, that's iLoc, never mind. You would have to do a combination of these at 2 different points, but wanted to say that that's how you can change the order of your columns if you ever wanted to do that. But yeah, likely you might be looking at subsets of data where maybe alcohol is greater than 14. That's how you do it. And that's kind of the idea behind this syntax. I think a lot of people get thrown off because you have like df twice in this line, but this is just saying that this is the condition on which you're locating from your data frame.
Can columns take conditionals too?
Columns can take conditionals as well. You don't do that very commonly, to be honest. I also don't know if I've done this before. Let's try that. df dot, I don't even know how I would do that. Yeah, I'm sure you can. I can't think of an example of how I would do this right now. Maybe instead of, because usually when you're looking at values, they go by rows, but technically you could do something like perhaps anything with like a letter, I don't know, a letter A in it. So, you can, it's just not often done. And I cannot think of a good example that will like have me spend a few minutes working through this, but I'm sure that you can. But good thought. I appreciate the thought. Okay, that's selecting. There are also other functions. Dot filter is actually something that's with the newest version of pandas, so you can do a dot filter as well. But yeah, okay. Really quickly, since we're looking at dot filter, I want to talk about documentation for pandas. So there's a lot of different methods that you can see just on the side here. There's so many different methods within pandas that you can use. This is only the ones that work on data frames. You can also do a bunch of series methods. So wanted to point out how you read documentation here. So one of the examples that we had was dot, let's use a different one. Let's use is NA. Where's is NA? Is NA, I is NA. Okay, here. And is NA and is null are very similar. So the way that you read this data frame is first you see what kind of data type it works on. So if you see your data frame dot is NA, that means that when you're doing dot is NA, it has to be connected to a variable that is assigned to a data frame. That's super important. If you try and do like a series method on a data frame, it's not going to work. An example being, let's just see what is a series one that is. I don't know if there are any like series ones that are strictly for series. Let me look for maybe an example the other way around. Okay, let's see, maybe, I wonder if pivot is something on data frame. Okay, so dot pivot I think is only a data frame one. So as an example, if I just have df alcohol, which is a series, if I do dot pivot, and dot pivot is a method, maybe it'll throw me an error, maybe it won't. There we go. It'll say that series object has no attribute pivot. If you try and do a series method on a data frame, it'll throw you this error if you try and do a data frame method on a series, but a lot of them do overlap. So if you just get this and you feel like it should work, check on your data type. Also, so with documentation, there are parameters and then also attributes. So as an example here for dot, let's not talk about dot pivot, that's a pretty tough one. Let's use read CSV. Read CSV. Let's just look for it directly. PD read CSV. There we go. Oh, another note is that earlier we had it working on a data frame or on a series. Sometimes they just come out of pandas straight away. So that's how you figure out whether you do PD dot or DF dot. You have to look at the documentation. So as you can see here, read CSV takes in a lot of different parameters. Most of the time, a lot of these are actually optional. But as an example, if you remember, read CSV was what we used over here to read in this one about cars. In the read CSV, you can take in a bunch of parameters. So this is how you figure out what do I feed in to a method. So parameters, there's parameters here. If you want to use like specific column names, you can do that. A lot of different things. If you run into any issues with working with a method, sometimes you can Google what the error message is, and it usually tells you to edit one of these things. So I know in the project that we're going to start next week, you're going to see that you're going to run into some issues, and I want you all to consult this documentation. But you can see here, what they do is Pandas is great. They always give you like a few examples. Like I know for, let's just look at some interesting ones that I know have good examples. Let's just look here. df join is one. So you can join data frames together. We'll talk about this tomorrow, actually. Lots of examples on what it'll look like. And they usually give like fairly simple examples so that you can refer. But yeah, Pandas I like because they actually recently revamped their entire documentation website. So it's a lot more organized now. And they always like refer you to like similar ones, especially if the ones that you're working on don't currently work. You can consult similar ones. Maybe those will work better. But yeah, cool. Let's see. Any questions at this point? Because the last few things I just want to wrap up. All right. Some things I wanted to point out. I'm not sure if they've moved this lesson, but there is a data privacy and ethics. So it's no longer here, but I think that was in like topic 1. There we go. Data privacy and data ethics. As you're starting to use more and more data that comes from everywhere, it's a good idea to think about the ethical implications of using data. There are a lot of like short courses on data ethics. And of course, I don't want you all to get very into that now, but it's a good idea to start thinking about, you know, what are the implications of using your data in a certain way. And as we get into more in-depth projects, we'll get into more of those like questions of, is what I'm doing okay or not? Also, in topic 4, they introduced something known as Kaggle. And I saw several people were already doing this over the weekend. Kaggle is a great platform for getting ideas for projects. Kaggle also has a lot of data sets. So if you feel like you don't have enough data to play around with, Kaggle is a good source. They just let you download a bunch of data. You can download them as CSV files if you want to just play around. If you see something that you're interested in, maybe you want to download the data set. Future projects, you'll be able to choose your own data set. So feel free to do that as well. If you see something interesting that you were like, maybe I want to save this data for use in the future. Of course, right now we don't know what our future projects are going to look like, but good to maybe like bookmark or something. So yeah, that's good. Next, tomorrow we're going to talk about more pandas methods using like lambdas as well. So I know I talked a bit about lambdas on Friday, but we're going to talk more about lambdas and how you can use them with series and data frames. We're going to talk about data cleaning techniques. And also, instead of talking about SQL for 2 days, I'm going to talk about visualization because we don't really have a visualizations topic, but I do think it's super important to understand some like syntactic things of visualization. So on Thursday, that's what I'm going to do. Cool. Just to recap, later this afternoon, I'm going to send out pairs to work on the project. So look out for that. I'll take into account your time zones. For those of you who don't, there are a couple people here that don't need to do the phase 1 project. I will let me know if you would like to be paired up. I'm more than happy to do that as well. So I'll be pairing you up to work on either the cumulative lab in topic 4 or in topic 5. Feel free to pick either one. Do both if you'd like. Tomorrow I'll talk about how you can like send that over to me, just for me to check that out. But yeah, does anyone have any questions before we close out? Cool. Well, there's nothing else. I'll talk to you all tomorrow to continue our pandas
One
work.
thing.
Oh, yeah.
One thing. Yeah. I seem to have had an issue with, let me see which lab it was. It was the Json Serialization Lab. I seem to have an issue running it locally.
Okay.
Every time I tried to import it, it gave me an error when I tried to load the JSON file.
Okay.
Let me see what the exact, but it worked in Lumidesk, just not locally. So I was able to get it done. I just don't know why it was throwing up error messages.
Yeah, if you can like screenshot the error and send it over to me.
Sure. Yeah, I'll do that. I can.
Yeah.
I'm not sure what it was doing, but it wasn't calling something correctly.
Okay. Yeah, throw it in the channel or something. I'm sure other people would have the same error if it's something like that.
And second question, if you're for the study group repo,
That's right.
if I clone it from one machine and want it on another machine, I just pull, correct?
If you want it on another machine, you would have to git clone it again.
Well, if I clone it already once and then
Oh.
I push it back,
Yes, then you just have to.
then
do a
I
git
just have to
pull.
do a git pull as long as I've
That's
taken
correct.
ownership of it and committed my own changes to it and then
That
pushed
is
it
right.
immediately. Okay. All right. That's all.
Awesome. Thanks, Justin. Yeah, anything else? Perfect. Well, there's a lot in pandas. Pandas can do so much. If you would like more like pandas practice, because pandas is something that we're going to be using through the rest of this program, I want to point you all to this extra pandas practice repo here. Great repo, and it's organized in different sections. Feel free to just fork and clone this. This is not owned by me, by the way. This is created by this guy. But a lot of students have found this helpful. There are like different data sets. For example, there's a Chipotle data set that you can just work through their exercises, and they have solutions. So they have solutions here, and there's also video walkthroughs for some of them. So this is actually really awesome. A lot of students have found this really helpful. Cool. Well, if there's nothing else, have a good rest of your day, everybody. I will see you all back here tomorrow or at your 101s. Bye, everybody.
Thank you. Bye.